In this video, we'll talk about the process of finding the total area contained between two curves. So we know that integrals give us the area under graphs when the function's positive. What if it's not positive? So if I have a function like sine of x, we know that I can find the area under positive parts of this by just doing an integral. So if I want to find the area of this chunk here, I could do that because that's a positive area, and I can find that as the integral from 0 to pi of sine of x dx would give me that area. This is negative cosine of x from 0 to pi, which ends up being 2. That's for the green area. What if I wanted this area? Well, if I do the integral, I'm going to get a negative number. Right? In this case, the integral from pi to 2 pi of sine of x dx, by the same logic, is negative 2. What does that mean? Well, that means this region here has area 2, but because it's below the x, it came with a negative sign. This is sort of the inverse of the positive negative signed areas we talked about before. The integral will always give the signed area, where it depends on whether it's positive or negative. And you have to take this into consideration when you're trying to figure out what the problem actually wants from you. If it wants a signed area, then just do it this way. But if it wants the actual area contained by these curves, you'll have to make sure you flip the sign wherever you need it to get the actual area and not cancel things out with these pluses and minus signs. So let's talk about a process here for how we find the area of these regions bordered by graphs of functions. What was the issue before? Well, the issue before happened at pi. What happened at pi? Well, pi is where sine crossed 0. The question before was something like find the area between the graphs of sine of x and 0 over the range from 0 to 2 pi. And we had an issue at pi because at pi, the integral went from being positive, with the region being above the axis, to negative, the region being below the axis. So how do I analyze this in general? Well, first I have to figure out where my function is 0 and where it crosses the axis. These are going to be my division points for computing different integrals to find these areas. So after you split the interval using these division points, you're going to compute the integral for each sub-area independently. And it's likely that some of these will be positive and some will be negative. Because they are integrals, they're not areas yet. If I want to make them all areas to just find the total area without caring if it's plus or minus, I want to make all these numbers positive and then add them up. So take the absolute value of all of them and add them up. And that will give you the total area between the two curves in this format, because you've gotten rid of that plus minus bit that was canceling out and just had them all be positive, so you add up total area. So as an example, find the area of the region between the x-axis and the graph of y equals x squared minus 2x over from 0 to 4. If we look at this graph, it looks something like this, where here's 0 and here's 4. So I've got a part here that's negative and a part here that's positive. So I'm going to have to do this in two separate parts. Where do I hit 0? Well, if I set x squared minus 2x equal to 0, I get x equals 0 or x equals 2. The important part here is the 2 because that's inside my interval. So I have to split this at 2. Now we're going to compute two integrals, one from 0 to 2 and then one from 2 to 4 to see what we get. So I'll do the 0 to 2 one first. 0 to 2 of x squared minus 2x dx is going to be x cubed over 3 minus x squared from 0 to 2. If I plug in 0, I get 0. If I plug in 2, I get 8 over 3 minus 4 and then minus 0. So I get a negative 4/3. That makes sense. This answer should be negative because this region was below the axis. Now for the other part. Integral from 2 to 4 of x squared minus 2x dx is the same function, x cubed over 3 minus x squared from 2 to 4. Now I plug in these numbers. I will get 4 cubed is 64 over 3 minus 16, and then minus 8 cubed minus 4. So this will come out to a 16 over 3 minus a negative 4 over 3, so I get 20 over 3. Now, if I want the total area to ask for in this problem, the total area is 20 over 3 plus 4 over 3. Absolute value and add them is 24 over 3, or 8. If I had done the signed area, I would have gotten 20 over 3 minus 4 over 3, which is 16 over 3. So the integral would have computed 16 over 3, but the actual total area is 8. So that's the idea of finding the total area between curves using integrals, and how you have to split things up to be able to solve these problems correctly to find the actual area, and not let the plus and minus areas cancel out if there are areas of different signs within this problem.